Welcome back to 30 Days of Physics with Miss B, and we're moving right along with pressure and buoyancy. Everyday objects, including people, can exert pressure onto other objects. A large force applied to a large surface area exerts a small amount of pressure on that surface. A large force applied to a small area exerts a large amount of pressure onto the surface. Health-wise, we could suffer from the effects of pressure. High blood pressure, medically referred to as hypertension, affects our health. If left undiagnosed, it could lead to a stroke, heart disease, heart attack, and kidney failure. It is a condition in which the force of the blood against the artery walls is too high due to the presence of plaques. These plaques arise due to stress, tobacco, a poor diet of high salt intake, medicine, fat and/or cholesterol, age, or genetics. Pressure is defined as the force acting normally per unit area, where pressure is equal to force divided by area. The SI unit of pressure is newtons per meter squared, and it is equivalent to 1 Pascal. In fluids, pressure increases with increasing depth and density. Mercury, at a depth of 1,000 cubic centimeters, exerts a larger pressure on the bottom of the vessel it is contained in than water would at the same depth. This is because mercury has a density of 13,600 kilograms per cubic meters, while water has a density of 1,000 kilogram per cubic meters. To determine the pressure in fluids, the following equation is used. Pressure in fluids is equal to density of liquid times its gravity times its height, where gravity is equal to 10 newtons per kilograms unless otherwise stated. Our bodies are exposed to atmospheric pressure every day. Atmospheric pressure is the pressure exerted onto all bodies, including our own. It is the weight of air upon us, but we do not feel it simply because it is equal to the pressure inside of our bodies. Atmospheric pressure has a value of 100,000 pascals. Atmospheric pressure is measured using instruments such as a mercury barometer or a manometer or U-tube. So you could call a manometer a U-tube. In liquids, pressure is the same in all directions at a particular depth. The lower down you go, the more intense the sprout of water. Since we're dealing with liquids, it's only fitting that we discuss principles that express a liquid's behavior when objects are immersed or floating in them. Let's learn about Archimedes' principle and the law of flotation. Archimedes' principle states that when a body is completely or partially immersed in a fluid, it experiences an upthrust equal to the weight of the fluid displaced. There is Archimedes in a tub of water that was filled to the brim. When he stepped inside, water spilled out, so he took up space. So the weight of water displaced from the bathtub is equal to the upthrust force he is experiencing currently, when he was alive. The law of flotation states that a body floats if its own weight is equal to the upthrust on it. That means the upthrust force is equal to the weight of the object. Let's try some questions. How much pressure is exerted onto the floor by a 60 kilogram box with base dimensions of 20 centimeters by 40 centimeters. Let's take gravity to be 10 newtons per kilograms. Pause the video to try the question. Well, if pressure is equal to force divided by area, we need to first determine the force. And to determine the force, we have mass. And mass, once it's being pulled on by gravity or acted on by gravity, you simply multiply it by that value to get 600 newtons. The area now of the base will be length by width, because we're speaking about a rectangle. And so we have 0.2 times 0.4. Yes. Remember, you have to convert 2 meters from centimeters. You want to use SI units all the way, and we get 0.08 meters squared. Divide 600 newtons by 0.08 meters squared, and you get a beautiful 7,500 newtons per meters squared. And you can just swap that newtons per meter squared with pascals to make it look very clean. Hope you got that answer. Here's another question. How much pressure does a scuba diver feel if she is 100 meters below sea level taking pictures of the ocean floor? Let's take gravity as 10 newtons per kilograms. The density of water is 1,000 kilograms per cubic meter. Yes. Pause the video to try the question. If you are bamboozled, please let the video flow. Breathe in, breathe out. Don't worry, you get it. Pressure in liquids is equal to rho GH. Rho represents the density of whatever liquid you're messing with. So in this case, we're dealing with water, and it's salty water, but because, you don't really want to go through all of that. It's water, whatever it is. And so we're going to use 1,000 kilograms per cubic meter. And why I'm saying that is because salt water should have a different density than actual pure water, but since we're not going into the logistics of that, we're going to just remain with the density of water unless otherwise stated. So in this case, we can just stick with the density of water itself, multiply that by gravity, which we have as 10 newtons per kilograms, multiply by the height. So depth can be height, so it represents height, because it's distance. So height is really distance, so you want to not be too technical with the words. So just remember, height, depth, distance, same thing. And so we get pressure is equal to 1 million pascals. From the question above, what would be the total pressure the scuba diver feels if atmospheric pressure is 10 to the 5th power pascals? All you would have to do to figure out the total pressure, you just simply add whatever you calculated earlier, which was 1 million pascals, to the atmospheric pressure that is in addition to what the scuba diver will be feeling, and you get 1.1 times 10 to the 6 pascals. Here's another one. What is the upthrust force on a floating object that has a mass of 0.5 kilograms? We're going to take gravity to be 10 newtons per kilograms. Pause the video to try the question. Objects float if their weight is equal to their upthrust force. Hence, weight of the object is equal to the upthrust force of the object. So you simply just have to convert the mass to weight by multiplying it with the value for gravity. We get 5 newtons from there. And it's good to note that here no resultant forces exist. The object will be either at rest or moving at constant velocity. And that's pretty much what floating is. Alright guys, I want to thank you for watching and subscribing to 30 Days of Physics with Miss B. See you tomorrow for day 13.